Okay, let's see how to use U substitution to integrate this function, natural log of x quantity squared divided by x. So I'm going to pick U here to be natural log of x. And now, picking the correct substitution when you're trying to integrate by substitution, that's a tricky matter. And it takes some experience, right, to get skilled at picking the U correctly. Sometimes there are some guidelines that we'll be able to use, to help us decide what we're going to substitute U for. In this example, just because we have natural log squared, that's just sort of suggestive to me that it might be beneficial to let U be equal to natural log of x. But if that doesn't work out properly, after we've taken a few steps, we realize we're not getting anywhere. We can go back to the drawing board and substitute U for another part of the integrand and see how that works. Okay, so sometimes this integration by substitution is a trial and error process. All right, now, so wherever we see natural log of x in this expression, we're going to substitute U. But it goes a little bit more than further than that. I need to actually replace or eliminate all of the x's from this integrand. So I want to completely change variables here in this integration problem from what was originally x to U, right? So I've got some other x's that eventually I want to eliminate here. I want to eliminate this x from the denominator, and I've also got to get rid of dx, right? Okay, so let's start here by trying to get rid of the dx, and maybe if we're lucky, we'll be able to get rid of the x easily as well, but I'm not sure of that yet. All right, so to get rid of the dx, first thing I'm going to do is I'm going to think of U as being a function of x because I have U equal natural log of x. And I'm going to take the derivative of U with respect to x, okay? So I get du dx, right, is equal to, of course, what's the derivative of natural log? Well, we've learned that, right? That's 1 over x. So I get du dx is equal to 1 over x. Now, I'm going to treat this equation as though I can solve this equation for dx. So I'm going to treat the left-hand side of this equation as though it were a fraction. It's actually something a little bit different from a fraction, but I'm going to treat it as a fraction, and I'm going to try to solve this equation for dx. All right, so let's see, how do I do that? Well, once you've done this a few times, you're going to get very good at it, and you'll be able to take shortcuts. But at first here, I'm going to just go through the full algebraic process of solving for both sides of this equation for dx. So I'm going to multiply both sides of the equation by dx. Of course, that will eliminate the dx's on the left-hand side, so I'll just have du here is equal to, and then on the right-hand side, I have 1 over x times dx, which is dx over x. Now, remember, what I'm trying to do is solve the equation for dx, because whatever I come up with for dx, I'm going to substitute that into my original integrand. Well, we can finish solving this equation for dx, right, by multiplying both sides by x, right? So this will divide out the x's on the right-hand side, and so I get dx is equal to x times du. Groovy. All right, that's what I'm going to substitute now for dx in my original integrand, right? Because that's what dx is equal to. So, finally, let's rewrite our original integral problem. So remember, I'm substituting U for natural log of x. So we'll write here U squared instead of natural log of x squared. The x hasn't gone away yet. I haven't been able to replace that yet. But I do know that dx is x times du, right? So wherever I see dx right here, I'm going to write x times du. And then a really lucky thing happens here, right? Okay, so this really tells me that I'm on the right track. the x's are going to divide out. So I end up here with just the integral of u squared du. And so notice now that I have managed to completely replace the variable x in my original integrand by my new variable u. And now I have kind of a new integration problem. I'm just integrating u squared. That is a very easy expression to integrate, right? Because there we can just use the power rule. So I have, oops, I'm integrating already, so we can erase the integrand now. So the integral sign now. So I have u cubed over 3, right? Add 1 to the power and divide by the new power, plus my arbitrary constant. So the integral sign now has gone away. I've actually carried out the integration. Now, I'm not quite finished yet. I'm happy to be this far, but I'm not quite finished yet, right? Because my original problem involved the variable x, not the variable u. So now I'm going to have to sort of undo the substitution that I did originally when I substituted natural log of x for u. Well, that's very easy to do, right? Because u is natural log of x. So wherever I see u, I'm going to write, instead of u, I'm going to write natural log of x. So I have natural log of x cubed over 3 plus my constant, and that is the antiderivative. So that works out pretty nicely, right? So when it works well, integration by substitution is really powerful and really helpful. We're going to be using it a lot this semester.